Starting recording. Okay, started by you. Let everyone know they are being included. Okay. So let's look at learning unit 4. It's the successive differentiation. So they say at the end of the learning unit, you should be able to differentiate successively. No, successive differentiation just means that you have something, you differentiate it to get something, and you differentiate it to get something. Now, do you remember the equation of motions, guys? Yes. Hello?
No.
Ah, engineers.
Yes.
Motion.
Some is.
Yes, we remember.
Yo!
Second derivative.
You have a displacement, you have a velocity, you have an acceleration. What do you start with? When you differentiate, that thing gives you something. And when you differentiate, that thing gives you something. What is that?
You differentiate displacement, it gives you velocity.
The first derivative is velocity and the second derivative is acceleration.
Guys.
Are you happy, man?
Displacement.
You can't talk.
The
You can't
first
talk all at the
velocity,
same time.
the first what?
When you
The
derive
first derivative is
differentiation,
velocity
it gives you velocity.
and the second derivative is acceleration.
Do you see that? So that's the importance of successive differentiation. It means you need to go and understand how you do the first derivative, how you do the second derivative. So can we please mute? Someone is talking, can they mute? Okay. So they say if you have y is equals to 3x squared plus 2x plus 3, then you have dy over dx is, so the first derivative is 6x plus 2. This derivative again can be differentiated. So the process is called successive differentiation. If you differentiate dy dx, you get d squared over dx squared, which is the second derivative. And if you differentiate that, you get the third derivative. And if you differentiate that, you get the fourth derivative, so on and so on. At some point, some functions, they become what? They become 0. Right?
Yes, yes.
But some functions you differentiate for the rest of your life and they'll be function. For example, if you differentiate sine x, you'll differentiate your whole life and it will never become 0. You can even find the millionth derivative. Now be careful. I might ask you to find the nth derivative. Are we all together?
Yo, 8. It's gonna be a long step.
Nth.
Oh, okay.
Oh.
The nth derivative. I might ask you in the exam or in the assignment.
Hey, at least you're letting us know, man.
So you'll say what nth it is.
Hmm?
So you're not telling us the nth term, or you just want the whole?
So you see example 1 says find which derivative is this? It's the third derivative, isn't it?
Yes.
And then me, I want you to find the nth derivative.
Okay, I see what you mean.
F to the power of n.
Yeah.
So I might ask it in the exam or in the assignment. I'm just giving you what I might ask and how I might ask things. Are we together?
So ma'am, when we solve the nth, we use that rule of working Lipizza's or something.
No, what you do is you differentiate and find a pattern.
Oh, I thought maybe we use that Leibniz rule or something.
Oh, like arithmetic, yeah. So.
Yes, you differentiate. At some point, you'll see a pattern. And then you say, oh, the nth derivative is this to the power of n to the power of n minus 1 and whatsoever. So if you find an example, bring it to class so that we save souls.
Yeah, please. So
yeah, please.
If you find an example, not me.
Yeah, I know you have a lot of them, ma'am. Just bring one. You have a lot of them there.
I don't. What if the one I want to bring is the one I want to ask in the exam?
You will change it.
You'll change and put B and say find beams for term.
That's not
okay,
nice.
let's go back to the work. If you have dot, three dots like this, it just means that you have to find the third derivative. And after that, after 3, they'll put a 4 like this and x, meaning that you have to find the fourth derivative. They don't put dot, 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 dots, 4 dots or 100 dots, right? So now, here they want you to find the third derivative. So meaning that you first differentiate y, then differentiate y the second time, and then differentiate y the third time. So meaning that dy over dx is equals to, what's the derivative of this? Tan 3x. What is the derivative of tan 3x?
3 sec, what? 3 sec.
3 sec squared. 3 sec
Thank
squared.
you. 3 sec squared. Like this.
3x.
Yes, 3x. 3x.
Thank you. That's your first derivative. Are we together?
Yes, ma'am. Yes, ma'am.
We are not done because we want the third derivative. So dy squared over dx squared is equals to, what's the derivative there?
It's gonna be
6.
sec 3x.
So what are you using?
Oh, we're not using product rule.
What are we?
We can use product rule, but what are you using when you're saying 6?
Can't we
Exponential.
simplify and move the 2 up outward?
The chain rule. You are using the chain rule. So you're saying this can be written as 3 open bracket sec 3x squared. Isn't that what you're saying?
Yes.
So the chain rule says that you first differentiate what's inside. So meaning that you take this 2 multiplied by 3. So this becomes 2 times 3 times 2 times sec 3x times the derivative of the inner function. So it's 2 minus 1, isn't it? Times the derivative. What is the derivative of sec 3x?
It's sec 3x multiplied by tan 3x.
So it's sec 3x multiplied by tan 3x. You know where to find these things, right, guys?
Yes, it's there on the
page 2. So then this
I
is
think there's a
equals to
3
6
missing in front of the sec 3x.
3x times sec 3x times 10 3x.
Times 3, ma'am, at the end.
Also times 3. Yes, thank you. So this is times 3. So this
Yes.
is 18 sec squared 3x times 10 3x.
Yes.
Now we are not done. We want to find the third derivative. So it's to the power of 3 dx to the power of 3 is equals to, what is the answer?
We resort to product rule.
Thank you. We do the product rule. So meaning we differentiate the first function. In this case, it's sec squared 3x. So it becomes 18. Let's write tan 3 the way it is, tan 3x. Then let's differentiate this one. So this becomes what? 2 sec 3x 2 minus 1, isn't it? Times sec 3x times 10 3x times 3. Do we agree?
Yes.
Thank you. Now we are done with this, so we differentiate this. So it's plus 18 sec squared 3x times the derivative of tan 3x is sec squared 3x times 3. Are we together there, guys?
Yes.
Okay. So what is 18 times 2 times 3?
54.
64.
54.
54. Okay, so it's 54. Then we have tan we have a tan 3x here, and we have a tan 3x here. So then we can write it as tan 3 squared, tan 3 squared x, like this. Am I missing something? Times sec squared 3x. Done. Okay, squared 3x, like this, right? And then what is 3 times 18 plus? Guys, you allowed calculators. We are second years. Don't remember what I said in first year.
I was thinking,
man.
we were allowed to use calculators.
I know, because those who I taught first year, not last year, but first year, they know. There are no calculators. Here you can use calculators. So what is 18 times 3?
Is it not? What is it?
162.
18 times 3.
It's 54.
54, man.
Guys, you said 18 times 2 times 3 is 54. Now you are saying 18 times 3 is 54.
No, it was
Man,
162
18 times
before.
2 times 3
162.
is 108.
It's 108.
Yes.
Then
Then 18 times
18
3 is
times
54.
3 is what?
54.
So this is sec squared and sec squared. So this is sec to the power of 4, 3x. Am I right, or did I make a mistake somewhere?
Somewhere, somehow.
Guys, were you not with me?
Ma'am, you made no mistake.
Made one mistake in the first
Okay.
question.
So then let's go and check.
It's 160. Something is wrong somewhere.
So where's the mistake that we made? Because the 64 is this one, isn't it? Where's the mistake here?
Ma'am, I think the mistake started when you included 18 times 3x. That's when the mistake started. Like there, I don't understand what happened there. Yeah.
Where?
Well, the third differentiation on the
Okay,
third
let's
one.
look at the first derivative. Are we okay with the first derivative, right?
Yes.
Yes.
And then let's look at the second derivative. Ne? Is the second derivative correct? Guys,
No.
where's the mistake?
No,
I don't see anything wrong.
no,
Okay,
no, ma'am.
let's go here.
Ma'am, the second one is not okay.
The second one is not supposed to what?
I'm saying it's not 18 tan 3x plus 18 tan cubed 3x. Yeah. Yeah. I think you did vice versa, I think.
18 times sec squared 3x times tan 3x. Right?
Yeah.
Is the same as 18 times tan 3x times sec squared x. Right? And then here, okay, let me see. Okay, I don't see anything wrong though. Does it make sense, guys? Hello?
Hey, ma'am, we seeing me, ma'am. That's why we are quiet. Trying to. We seeing me,
You
ma'am.
seeing what?
Me. It's tough. That's why we are quiet.
No,
Okay,
ma'am.
this is what I noticed, right? If we differentiate this part, we can also change this into an identity to make it simple. This one, right? So there are two ways of doing it. We can change this into an identity, or we can continue differentiating like this. Are we together?
I think
Okay.
Yes.
the difference with
So wait, sorry, let me continue with this part first
okay.
and see
Yeah.
if we still get this. So you can continue like this, or you can find you can use the identity of sec squared. Do you see that? So let's differentiate this. What do we get?
So
Can we differentiate again and see what we get? So if we start differentiating the first one here, right? Do you agree that it will be 18 times 2 sec 3 x times 3. Do you agree, guys?
yes, ma'am.
Yes or no? Because I see a lot of people are quiet.
Yes, ma'am.
Okay.
Yes.
Times 10 of 3x, right? Plus, now we have 18. We leave this the way it is, sec squared 3x times the derivative of 10. We know it's sec squared 3x times 3. Do you see that?
Yes, ma'am.
Right? Something is missing here, guys.
Yeah, ma'am. I think if we use the identities to be better.
Okay, let's start with the one without the identity.
Because this one is a long one, yeah, but it's fine.
Yeah, I see it's becoming long. Something is missing here. So let's start differentiating. So we have 18 times
2.
Can we differentiate sec squared 3x on the side? What do we get? We get 2 sec 3x times sec 3x times 3. Is it true?
Yes, ma'am.
Okay. So then we get 2 sec 3x times sec 3x times 3 times 10 3x.
3x
Ma'am, hello, ma'am.
Yes.
plus.
Yes.
If you differentiate sec, you get sec tan. You don't get sec alone. You get sec
Yes.
tan. It's never sec alone. It's when you start differentiating sec, it gives you sec tan. It gives you sec tan x.
Thank you. So can we do that? So it's 18 times, let's differentiate sec. So we agreed it will be 2 times sec 3x, right?
Yes.
Yes.
Times the derivative of sec 3x. What is the derivative of sec 3x? It's
no, ma'am. You don't go there. You don't go there first. You come back to sec alone, sec 3x alone.
Yes, isn't that what we are doing? The chain rule. Can we differentiate sec 3x sec squared 3x on its own? Because we want to differentiate that.
Yes, it's gonna
So
be
this becomes what?
2 sec
2
3x.
sec 3x times the derivative of sec 3x. What is the derivative of sec 3x?
It's sec 3x tan 3x times 3.
Thank you. Times 3. Thank you. So meaning that this, let's simplify it, it becomes 2 sec squared 3x times 10 3x, isn't it? This 3 times 3, so this becomes 6. Do we agree there?
Oh yeah.
Do we agree?
3
Yes or
times
no,
2.
guys?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So let's put it here. So it's 18 times, yeah, this is long.
6.
Sec squared 3x 10 3x times 10 3x. Are we together there?
Yes, ma'am. Plus
Okay. Then we are done with that part. So now plus 18, we leave the sec squared the way it is, square 3x. Now we differentiate tan x, which is sec squared 3x times 3. Do we agree there?
yes.
So then this is equals to 18 times 6 is what? Guys, what is 18 times 6?
108.
100.
So it's 108. And then we have sec squared 3x times 10 squared 3x plus 18 times 3 is it 54?
Yes.
Yes.
Yes, 54.
Sec to the power of 4, 3x, right? So meaning that is when we didn't apply the identity here. Are we all okay with that one?
Yes.
Yes, ma'am.
So now when we apply the identity, it might look different. Let's see when we apply the identity from this step here. I think the identity will make it 10 here. So we know that dy over dx. Can we apply the identity here, guys?
Yes, you can, ma'am.
We can.
So it's
Yes,
18.
ma'am.
What is the identity of sec squared? 3x.
It's
1 plus
1 plus 10
10
squared
squared
3x.
3x.
Okay. So it's 1 plus 10 squared 3x.
3x.
Are you sure?
Oh, yes.
Okay.
And
10
10
3x.
3x.
So this makes it easier because we then have 18 times tan 3x plus tan cube 3x. Do you see why it makes it more easier when we use the identity? So then this will be equals to, oh sorry, this is the second derivative. So this will be equals to 18 tan 3x plus 18 tan cube 3x. So what is the third derivative then?
So it's gonna be sec 18 sec squared 3x
Times 2.
multiplied by 3
Mhm.
plus
18.
18 sec cubed.
There's a 3 here.
Yeah, it's sec cube. No. Oh,
Sec cubed.
no, sorry, ma'am.
54.
It's what? Guys, what's the derivative of 10 cubed x? What is the derivative of that?
How we gonna use a chain rule?
It's gonna be 3 tan
Mhm.
squared. Yeah, 3 squared 3x is into sec squared 3x times 3.
I'm sorry.
That's squared 3x times 3.
Is that clear, guys?
Yes,
Yes,
it's gonna be
ma'am.
Okay. So let's go and put it. So that is the derivative of this, isn't it? So it's 3 tan squared 3x times sec squared 3x times 3.
And also, ma'am, you can manipulate that tan squared 3x.
Which one?
The one to on this the tan squared 3x, we can still manipulate it and then make it a sec.
But you see, when you make it a sec, the step will be longer, like what we did in the previous example.
Oh. I just thought we can manipulate it and make it the. Oh, I see. It's gonna be.
It's gonna be longer. That's why I said if we use the identity on this problem, we might have a shorter step compared to the previous example, the way we did it previously.
Okay.
So this one will be 54 sec squared 3x.
3x, yeah.
Plus what? 18 times 3 is what?
160.
162.
162, that's the final answer.
18 times 3 times 3.
Yes. So tan squared 3x sec squared 3x. Do you see that the answers are different, guys?
Yeah.
Yeah.
The two answers are different, but the methods are correct. This one, we didn't change what's this? We didn't change this to identity. And when we didn't change that to identity, did you notice how many mistakes we had?
Yeah, because it becomes longer. So you jump some when you have to derivative something, you jump. So when you add, there's not a problem.
Thank you. So what happened is sometimes if you don't change them to identity, then the steps become longer, then you become confused as well, right? But it doesn't mean that you are incorrect. In this one, we changed into the identity, and this is what we got.
Ma'am, in this case, we got 108, and on this one we got 162. So in that regard, aren't you gonna like mark that one because our constant are not the same?
I'll mark both of them because so if you notice, the things are not the same. Look at this. This has sec squared, 10 squared, and whatsoever. The constants are not the same, but you didn't change this into an identity, right? If you didn't change this into an identity, chances are we might not end up in the same with the same answers. So we need to go back and check. Let's see in the study guide which one they used.
They changed it.
So they changed into an identity, right?
Oh.
So meaning that's why they have fewer steps. But if you don't change it into an identity, go and check if this is what you get if you don't change it into an identity. But I think we should get the same answer. Why are we not getting the same answer?
Yeah, so constant must be the same.
The constant
I'm redoing it, ma'am. On my side, I am getting 162, but I'm still busy with it. It's almost the same.
Yeah, thank you. It means the answer should be the same if we don't change into identity. But even if it's long. We just need to see why we're not, because this one is the same, but what about the other one? Can you see where the mistake is? So we're not changing it to an identity for now because we did that. Let's see. We don't change this into an identity. What's that? Can we differentiate? Is this correct? Let's start there. This is correct, right?
We are getting the same thing, ma'am. Now, we are getting 18 set to, because we only change it when we found the sec to the power 3x. Then is when we applied the identity. So our steps and the study guide is the same, according to me. I'm looking at both of them.
Okay, so let's not do, what's this? Let's not change to the identity the way they did it here, right? So we stop here and differentiate from here. Let's differentiate from here instead of changing into the identity, which is this one here, right? So here we use the chain rule. Can we differentiate sec squared 3x separately? What's the derivative there? Is it 2 sec 3x, right? Times sec x tan x. Oh, 3 here, sorry. Times 3. Guys? Hello?
Yes, ma'am, that's correct. But yeah, that's
Okay.
what caught us out. Yes, ma'am.
So now, this becomes, this times, this becomes what? It becomes 6 sec squared 3x times tan 3x. Right?
Yeah.
Correct.
So let's go and substitute it. So then this is equals to 18 times 6 sec squared 3x times tan 3x times tan 3x. Are we all okay there?
Yeah.
Yes.
Yes, ma'am.
It takes us back to 108.
Wait for it.
It will take us back to 108.
I think without using identity, we can't get the answer here.
Yeah, we can't.
No, it's still correct, guys. It's still correct.
Okay, let's continue.
Yes, it's still correct.
But now we have to
let's continue.
differentiate tan 3x, huh?
Yes.
So it's plus.
No, it's still correct. Because if it takes us back to 1 without the identity.
But let's carry on. Let's see how far we get, ma'am.
Plus, let's see, plus, what's the derivative? So it's 18 sec squared 3x.
Sorry, ma'am. Can
Yes.
I ask some? The 6 there, 6 sec 3x. Where did you get the 6? Because I'm seeing
We
this.
differentiated this.
For sure.
We differentiated that.
Okay.
Can we go back to our standards? I don't know whether I'm tired or I'm missing something here.
Page 18.
Where is it? Our standard
18.
table on page 2. It says when you differentiate sec x, right? You get sec x times 10x times the derivative of sec x. Right? So meaning that if I have so I had d squared y over dx squared is equals to 18 sec squared x 3 tan 3x. So then the third derivative of this x3 is equal to, let me differentiate this first. If I differentiate this first, then I get 18 sec squared 3x times sec squared 3x times 3. Are we together?
Yes, ma'am.
Yes.
Okay. Now let's differentiate this part. So then this is plus 18. What is the derivative of sec squared?
The sec squared part is gonna be yes.
Sec squared 3x is gonna be what?
It's gonna be 2 sec 3x.
So meaning that this is gonna be
2 sec
times
3x.
sec 3x
3x
times
yes.
the derivative of sec 3x, which is sec 3x times tan 3x
x
times 3.
Yes.
So which is equals to 6 sec squared 3x times 3x.
Yes.
So then
Yes.
this 6, yes?
I think the answer is going to be different if you do it this way without using the product rule after, because there's a multiplication sign between these two. So
yes,
I think
that's what I'm thinking as well.
Yeah,
so it
it's
means
supposed
that
to be the product rule.
Yes, it means that if we don't change it into an identity, we won't get the same answer, but the method is correct.
Yes, so it's either we change it or we use the product rule when you're doing the product rule for the third order.
Yes, I agree.
I think
ma'am.
Whatever he's saying.
Ma'am, my question.
Okay. One person at a time, one person at a time.
Yes, please.
Yeah, my question was regarding the 6, like where you got the 6 here. Did you take out the 3 from sec 3x tan 3x and then multiply by these two? Okay.
So remember what, with the chain rule, you take the 2 at the bottom, right? And then you minus 2, then you differentiate sec 3x, you get tan sec 3x times 3x, and then you go differentiate whatever is inside, which is 3 here. So that's where the 6 comes in.
Okay.
Yes. So then this becomes sec squared 3x times 10 3x. So it takes us back to, it means we were correct, Mos.
So I think without converting to identities.
No, ma'am, we were not correct on the first one. If we don't want to use the identity, we are forced to use the product rule on our method, on our first method.
That's what I'm saying. On this method, we are forced to use the product rule, isn't it? Because we didn't change the to identity. So what is 18 times 3? It's still 54, right?
No, it's 162. It's 162, yes. So it's the same as the answer in the book.
So then where did we go wrong?
Times 3. He said times 3, not times 6. Times 3.
So let's do 18 times 3 is what? 54.
It's 54.
It's 54.
Sec to the power of 4 3x, right?
Yeah.
Then 18 times 6 is what?
108.
108.
No, can't be 108.
It's 108.
What did I do? Yeah, it's 108. Because I multiplied on 18 times 3. I multiplied 18 times what? Times 3, and then I took 54 times 3. That's why it gave me 160. Why did I do that?
You multiply 18 times 2 times 3, isn't it?
No, I multiplied 18 times 3 first. Then on the other end, when I included the second phase of task, that's when I multiplied that 3. I didn't multiply it at all. I didn't multiply 3 times 3. Then it gave us 6. Then that's when, because according to the law of Godmas, okay, we, according to this thing, we started if we differentiate 18 sec squared 3x, if we differentiate that alone and then take that 3, multiply it by 18 and leave it like that, it will give us 54. Right? Then when we include that multiplication of that comes with the tan, as when we can multiply that 3 that comes with it.
But I don't think I'm getting what he's saying.
So where did the other 3 come from?
Which 3?
Can I
Which 3?
Ma'am?
Yes.
So on the second was it our second derivative where we got our 18 tan 3x plus 18? No, we didn't. Sorry. Wait.
Because I think we want to check if we use the identity and we don't use the identity, are we getting to the same answer now? That's the question.
No.
We are not getting to the same answer.
Yes.
Okay.
Yeah. My question is that how is can we just go back to where we got that 108?
We use the chain rule. Differentiate this using the chain rule.
Because I don't understand how 3 times 3 is 9.
Okay, can you mute? Let's focus on this again.
I think,
so in the study guide, they changed this part here into an identity, sec squared, into an identity, right? That's why it made it easier for them to differentiate. Now, our aim is that, let's say we don't change it into sec squared. Are we getting the same answer? That's the question that that I'm asking here, right? So then you apply the chain rule. Is our second derivative the same as the study guide? Are we correct? Let's start there. Is our second derivative the same?
Yes, ma'am.
Yes. It's the same, right?
Yes.
Sharp. Now, if the second derivative is the same, so we agree that our second derivative is sec 18 sec squared 3x times 3x, right?
Yes, ma'am.
Yes,
okay. Now, when you are here to find the third derivative, you have to apply the chain rule. So with me, let me start with this one because it's easier. Let's differentiate this function. What is the derivative of 3 tan x? We know that the derivative of tan 3x is what? It's sec squared 3x times 3.
Times 3, yes, ma'am.
We are together, right? So then this becomes 18 sec squared 3x. This one here remains like that, times sec squared 3x times 3. Now we go and say, okay, plus 18. We want the derivative of sec squared 3x now. So let's write the 18 tan 3x the way it is. Give me the derivative of sec squared 3x. What is the derivative of sec squared 3x?
It's going to be 2.
2
3x.
Sec 3x.
Sec
3x.
Times
sec 3x.
Times
10 3x
times
3
times 3. Do you notice that if you don't change it to an identity, you end up having something long, which then at some point confuses you?
Yeah.
So meaning that now this 3 times this 2 gives us what? 6. Sec 3x times sec 3x gives us sec squared 3x times 10 3x. So meaning that here we have 6 sec squared 3x times 10 squared 3x. No, not times 10, not times squared, ne? It's 10
not squared, not squared.
Thank you. So meaning that if we go and simplify this, so this becomes 54 sec squared 3x no, to the power 4 plus 6 times 18. What do you get? 108 still.
Which is 108 sec squared 3x.
Sorry, ma'am.
108 sec squared 3x.
So we're getting the same answer. That's what I'm seeing.
Tan squared 3x.
So it means that The reason why we're not getting the same answer, the one in the study guide, it's because in this one, we didn't change into an identity. Does it make sense? The other one, we changed into an identity. So the answers are a bit different. Don't get confused.
Okay. Can you take out a 6 squared 3x as a common factor?
Yes, I think that's how we get the 106, because 54 plus 108 does equal to 162. So if we, instead of combining the sec...
No, you can't do that.
Oh.
You have to combine them.
So they'll never be combined, even if you take sec squared 3x.
Yeah, you don't. Yeah, I'm saying already. Yeah.
Oh, but you can take a 6 squared 3x and then write it out as a more simpler form like that, ma'am. Can you?
Yeah, you can do that.
Okay.
Yes. So here the point is that if you use an identity, you will not get. Chances are, if you use the identity and don't use an identity, you may not get the final answer to be the same. But the method is correct.
My question is, seeing that you will not be the only marker and other people will have the memo, you know, if someone is marking that as not so inclined to the math and they're only going according to memo, will they be able to see that, no, actually, a different methodology was used, yet it's still correct?
Remember when it comes to marking, right? We don't follow the memo exactly the way it is. I have to follow your steps. Because, for example, if I don't say use the quotient rule for this problem and someone used the quotient rule instead of the logarithmic rule, I have to mark them correct. So it means I have to follow the steps on how they did their work.
Okay, ma'am.
Does it make sense? Because everything we did here is correct. That's why we even ended. That's why I was checking. We're still ending at 108.
We will not be at a disadvantage as students, right? For giving this answer.
No. You will not. Here is that one person we didn't change the identity. In the study guide, they changed the identity. And we noticed that in the study guide, by changing the identity, it makes the steps few. For us, by not changing the identity, we end up doing the problem 3 times and still getting to the same answer.
So I'm getting this, one thing you need to factor in is time. You know, it's still a 2-hour paper, so you must choose your steps wisely.
Yes, basically. But when we mark, you will notice that we check all your steps. All your steps. The only difference here was that the identity was used and the identity was not used.
Yes. I hope the mark allocation is worth it. I'm saying I hope the mark allocation in the exam is worth it.
That's true. That's what I'm saying, that one method will give you a long step, like us not choosing an identity. We kept on making mistakes and whatever and getting up to the same point. But in the study guide, if you choose an identity, you get easier steps. The mark allocation will be what? Will be the same. But someone will write 10 pages for something they can write in 10 lines for something they can write in 2 lines. Yes?
What if the trick was to use identity? And then we will be penalized for that.
You won't be penalized because I didn't say use the identity. Do you understand? You won't be penalized. All the steps are correct. All the steps are correct. So in this case, we got different answers because we didn't use the identity.
Oh man, so that brings up another question. So when we're practicing the post-test, if my final answer is completely different to the final answer in the post-test, does it mean I'm wrong or I just use a different methodology?
That's why I'm saying bring it to me. Let me check.
Okay.
Yes. Bring it to me. Let me check. Because at some point you might have simplified the answer, or you might have not simplified the answer, or you might be wrong. So that's why I'm saying bring it to me. Let me check the steps. Then we'll decide from there.
Ma'am, so we are allowed to try, for example, this very same equation. or any other equation that relates to everything we are doing here, and then send you an email maybe just to check if what we are doing is correct. Are we allowed to?
People have been doing that.
Okay.
People have been doing that, yes.
Ma'am, I think the biggest lesson here is just to not ignore other rules of mathematics, just to be broad. Yeah, that's the only thing I could say.
That's true. So we were on successive, right? Look at us. It took us a long time, but then we ended up not getting the same. What's this? We ended up not getting the same answer, meaning that if you then use the identity and don't use the identity, chances are you might not get to the same answer. So with the post-test, if you happen to not get to the same answer and you tried it the second time and not get to the same answer, then send me the problem. Let me see where your mistake is.
Okay.
Are we together there?
Yes, ma'am.
Yes.
Thank you.
Very
now let's do do we still have time, guys?
We're 30 minutes late, ma'am. We're 30 minutes late.
So it means you go and do example 2 by yourself and example 4. And example 4, it looks long.
Yeah.
And then if you have a problem, then you come back to me.
Frustration.
Yes.
Can't we do example 4, man, before you let us go? You know.
Someone is asking if we can do example 4.
Yes, please, man.
Yeah.
I'm here, man. We're ready.
Yeah, ready.
But can someone please put all the examples and pages that we have to do in the math WhatsApp group?
You do all the questions in the math group. I mean, the study guide, do all the post-test questions and activities of what we covered.
Okay, sharp. But okay, it's fine. Okay, sharp.
Okay. Now, let's look at the problem. Which method are you going to use? Let's start there. Guys?
Yeah, we're thinking, man.
And be very careful.
Can we not use... Yeah, can we not use chain rule first?
I was thinking so. But ma'am, what's the question?
You can start with chain rule, ma'am.
So what they're saying is prove that x squared minus 1 times the second derivative of y plus x times the second derivative of the first derivative of x minus y is equals to 0. So what do we do here?
First, find the first derivative using chain rule.
Okay, so we want to find the first derivative here, and then we go and find the second derivative, where we need to be very careful so that we don't make mistakes. So then dy, let's find the first derivative. Dy over dx is equals to what? One mistake here, we are fired. So this is equals to?
We have 3.
Wait, let's simplify this first. Y is equals to x. Do you agree we have to simplify it here?
Yes, because we can't do... There is no room for root.
Yes. So then we have dy over dx is equals to 3x plus x squared minus 1 to the power of half. 3 minus 1 times, what's the derivative inside?
1 plus 1 over 2.
1 plus half
1 over 2.
Everything inside the bracket x.
To the power of negative half. Do you agree?
Yes.
Yes, ma'am.
Yes.
Okay.
X,
Then
Times.
Times 2x.
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 Times 2x.
Inside the bracket, before the bracket, inside.
Oh, sorry. Times 2x.
Yeah.
Okay. I hope we haven't made any mistakes so far.
This is a this on me in a bomb right now.
Are we okay? That's fine. Are we correct?
No, why don't we just use it without changing it?
It's because there's no derivative of a square root.
But if we're using chain rule, now let's continue. I'm trying something here.
What's the derivative of square root of x squared plus minus 1?
I get your point.
Okay. Now we haven't done any mistake here, guys.
No.
I hope not.
Yeah. I hope not. 3x plus, so this becomes x squared minus 1 to the power of half squared times 1 plus 1 over 2. Do you agree to the power of half becomes 1 over x squared minus 1 to the power of half?
Yes.
So this becomes 1 over x squared minus 1 to the power of half times 2x. So this 2 divides this 2. So it means that this is equals to 3x plus x squared minus 1 over 2 squared. Are you watching, right, so that I don't make a mistake?
Yes, we are
watching.
Thank you. So then this becomes 1 plus x over x squared minus 1 to the power of 1 over 2. Are we together then?
Yes.
Yes.
So normally I don't like, what's this? I don't like leaving it like this. I prefer simplifying it. So can we simplify it?
Okay.
So this is equals to 3x plus x squared minus 1 to the power of 1 over 2 squared. And here, remember, we said that because it's a 1 here, this is the same as 1 over 1. We agree, right? So then we take the denominator this side, multiply this side. So it's 1 over 1 times x squared minus 1 to the power of half over x squared minus 1, right, to the power of half, plus x over x squared minus 1 to the power of half. Let's say the denominator was different this side, so you take times 1 over 1. Are we all together up to that point?
Yes.
Yes, ma'am.
Yes.
So then this is equals to 3x plus x squared minus 1. Yes.
I think you made a mistake. That 2x multiply the bracket of 1 plus 1 over 2 into x squared minus 1 to the power of minus 1 over 2. It doesn't just multiply the 1 over 2 with to the power of minus 1 over 2.
Where?
The first derivative, because remember that we have the first
where here?
Yeah, yes, the first one. Yes, 2x is the derivative of the inner function.
Yes.
So it makes the whole steps from there be wrong, because at the end you are supposed to multiply by 2x, 1 over 2, And then that one also was supposed to be multiplied by 2x.
No, 0.
No.
It's gonna be 0.
Confusing yourself.
Okay, you're confusing yourself. Look at this.
So, ma'am, right now we are multiplying from the top, right? We did the
Okay, let's
derivative.
start here.
What we did there is that the first one is right, and then the second one, instead of
Yes, continue.
yes, the second one, the second inner function. The second inner function is 1 plus, and then we take that 1/2 from the top there. It's 1/2 into x minus 1, right?
X squared
Bracket.
minus 1.
Yes, x squared minus 1, bracket, 1/2 minus 1 minus 1, right? We are going to be left with minus 1/2. That is the second inner function. And then we get the inner function of the x squared minus 1, which is going to be 2x minus 0.
Which is this one.
Yes. So right now, my challenge is that you did the bracket on the outside, whereas it's going to exclude the 2x that is going to multiply also 1.
No, I disagree. Let me show you.
I think the 2x is a derivative of that x squared. I think
yes, it was a derivative of the inner
it's a derivative
function.
of x squared of the
So
inner
the
function.
inner
So they go
function is
together.
this one, isn't it? You agree with me, right?
So, ma'am, that one, yes, that whole thing is the inner function, right?
Yes.
And then
which is x plus x squared.
Ma'am, just separate everything. Separate everything. Do everything separately and do the derivative so it can be clear.
Do you see that?
Just
So now give me the derivative of this.
In this case, the derivative here is going to be 1 plus 1/2 into x squared minus 1. And then bracket minus 1/2. And then you are going to have the derivative of the inner function in this function, which is x squared minus 1.
Yeah, and what is the derivative of x squared minus 1?
It's 2x.
Yes.
So the problem is that the 2x don't only multiply 1/2 into, oh yeah, I see.
You are sorted now.
Yeah, I see it.
Yeah, no comrade left behind.
I don't want anyone to be left behind.
All
So
right, moving on. Back to where we were resuming, man.
Okay, so now we have x squared minus 1 to the power of half plus x over x squared minus 1 to the power of half. Do you see that, guys? After simplifying.
Wait, what happened to the other x squared minus 1 over half the denominator? Oh yeah, no, I see them, man. I see. You didn't have multiple, okay.
So now this simplified is equals to 3x plus x squared minus 1 to the power of half to the power of 3 over, yes?
Yeah, I'm lost on the denominator. The denominator won't be 1 to the power of 1. Like when we multiply them is oh no, it's okay. No, so I'm fine.
maybe you needed to write that simplified one to show how you get the common denominator on the side every time you do this.
Yeah, no, okay, I know it's okay. You can continue, man.
Ma'am, your exponent's 2. Why is it 3?
It's because when I simplified this part here, right, I got x plus x squared minus to the power of what? To the power of half, which is the same as this one. x plus x. So it's to the power of 3.
Oh, okay. Oh, okay. I was confused. It was swapped around. That's what got me. Okay, I see.
So that's the first derivative.
I'm still lost, ma'am. Please, can you reiterate that?
Okay, when I simplify it here, do you see when I simplified here? Let's look at this part here. When I simplified it, right?
Which part?
I got x squared minus 1 to the power of half plus x. Do you see that? Which is the same as x plus x squared minus 1 to the power of half squared. So this and this are the same. So if bases are the same, what do? I add the exponent. So that's why I'm getting to the power of 3. Did I lose anyone there?
No, that makes sense. Yeah, it makes sense.
Okay,
My
let's go and
question is-
check.
My
Yes,
question
your
is,
question is?
how did you foresee that when you simplified it, you knew that the numerator will be the same as your function outside of the bracket?
I didn't foresee that. I just noticed if I leave it like this, it will give me a problem if I leave it like this, it will give me a problem when I have to do the second derivative. That's why I simplified it. It's not something I foresee. Yes.
Oh, it's a coincidence. Okay.
Yeah, it's a coincidence in this case. Is that if I left it like this, I can see from here, because then I have to multiply this by this one, this by 2, and then I have something very long. But if I simplify it, then I'll just have a function multiplied by a function and give me something very simple like this.
Okay.
Not that I foresee it that the numerator will be the same as the numerator. No.
Okay.
Yes. So let's go check if we are correct up to that step, because I don't want to continue something. And yes, we are correct. Do we see that?
Yes, ma'am. The only thing we're missing is we didn't reverse simplify it, so you're supposed to take it back to its root form.
No, for me, I don't like taking it back to its root form because it might confuse me when it comes to derivative. At this point, you're on page 34, so they assume that you know the derivative of a square root.
Oh, okay.
Because you have done so many post examples by now. So meaning up to that point, we are what? We are correct, isn't it?
Yes. We are finished with the first derivative. Now we can move on to the second.
Yes. So let's move on to the second derivative.
Sorry, I have a question.
Yes.
Right, so you don't expect us to put it back to root form? You can just put it in power form like that, né?
No.
Like that.
Remember, we are going to look for the, listen to this. Remember, we're going to look for the second derivative. That's why I'm leaving it in a power form, because I know it might confuse me when it comes to the second derivative. But if this was the final answer, then please put it in root form.
All right.
Are we together?
Yes.
So yes, then put it in root form. If this was just the final answer, put it in root form. But because now I want to find the second derivative, that's why I'm still putting it in what? In the power form. Basically. Hey, why is it turning? Yeah. So then this is dy over dx. Yeah. So now we want to find the second derivative, right? So we need to be very careful. In this point, what do we use?
Quotient rule. Quotient rule, but I don't like quotient rule.
At this point, do you have any choice?
No. Yeah, we do, man. Well, let's take out the brackets. I mean, not the fraction. Separate the two.
It will give you a chain rule still, and then it will make you have to go back to quotient after.
Okay.
So let's use the quotient rule. I thought someone would say we use the logarithmic rule.
I wanted to say that, man.
This is not y, it's still y.
Yeah, I
Are we
can
together?
see. Yeah.
This is the y. Because my mind was like someone would say we use logarithmic. This is the y, not y. So it means in this case we have no choice but to use what?
Quotient.
The quotient rule. So let's do that.
Khalifa, can you mute your mic, please?
So dy squared. Guys, do you see how I'm representing? Someone will continue here and do the quotient rule.
That one's
so let's be careful. The first one, we put it the way it is. X squared minus 1 to the power of half times. Come on, help me. So do you agree this times this is 9? So
yes.
It's 9 x plus x squared minus what am I doing here? Okay. Yeah, I'm tired now. So it's x plus x squared minus 1 to the power of half, right? Squared.
Yes,
Am I right?
that's correct.
Yes, ma'am. Times the inner function. In this case, the inner function is 1 plus x squared minus
1 plus half.
a half
Times, yes.
x squared minus 1 to the power of negative half times 2x.
Yes.
Am I right?
Correct.
Yeah.
Yes, you're right.
Yes. Yeah.
Yes.
Wait, what
That
about
was
the
wrong.
wait? What about the inner function, the x squared minus 1?
Yeah.
That's the 2x.
Or maybe let me write it here. 2x
Oh, okay.
minus 1 over 2 x squared minus 1 to the power of negative 1 over 2 times 2x times 3x plus x squared minus 1 over 2 to the power of 3 over x squared minus 1 to the power of 1 over 2 to the power of 2.
This is why I don't like quotient rule.
We have no choice but to do it. Guys, are you following? Am I doing the right thing?
Yes, man. But hey, there's some spaghetti right here.
Hey.
Okay. Now, let's simplify. Help me. Okay. Do you agree that this and this two, they remove each other?
Yes.
Okay. So meaning that we have
x
squared minus 1 to the power of a half times, let's see in here, we have 1 plus x squared minus 1 to the power of negative a half.
They leave 1, ma'am, isn't it?
Yes. Times x times 9x plus x squared minus 1 to the power of half to the power of 2.
Yes.
And this 2 and this 2, they also do something there.
So it's 3x. Minus 3x.
So this is minus x squared minus 1 to the power of negative 1 over 2 times 3x times x plus x squared minus 1 to the power of 1 over 2 to the power of 3 over Hey, that's why I don't like quotient rule.
Ma'am, okay, I know you said my original idea would lead us back to quotient rule, but would I be wrong is, okay, cool. This is like, I'm spitballing here. Can you go back to the first equation? I'm going to try and manipulate. Okay. Would I be wrong if, cool, I separate, right? It'll be 1 over x squared minus 1 to the power of half, right? Would I be wrong if I turn that into, my exponent will be negative half. So now I can just apply
chain rule.
Yeah, chain rule.
Product rule. You won't be wrong.
Mm-hmm.
You won't be wrong. It's actually correct as well. You won't be wrong. But at the end of the day, you have to then simplify it as well. Okay, guys. What do we see from here? Do we agree that this will be x squared minus 1 to the power of 1 over 2? And this over here will be
3. Also 9.
in here. If you simplify this, can you simplify this on the side? Do you agree that that will be
X over x squared minus 1 to the power of half? Oh, I forgot about the plus 1.
Do we agree?
Oh, yeah. Common denominator.
Do we see that, guys? I know we are tired, guys. I understand.
No, it makes sense. It makes sense.
Okay. Because I see a lot of people are not responding anymore.
No,
ma'am, we are still following through.
Not even responding. Some they ran away. We were 100. So now 67.
Hunger. Sorry, ma'am. You remove the 2 by cancelling from the one on the top, but I think you still removed it. I don't understand. X squared minus 1 over half squared. So you remove that squared by doing what? Cancelling with the one on top.
Which one?
There's x squared minus 1 half there on top. You see it before the step you are writing now.
There's a common.
And there's x squared minus 1 half squared, the denominator.
You mean this one? Yeah?
I can't see where. No, the other one. The first one.
The first one? This one?
Yes. Yeah. Oh. Yes.
I wrote it here. I haven't done anything to it.
No, I thought you removed the... Can't you do that? Can't you cancel the one beneath?
Yes, I will. Isn't that we are simplifying step by step? I see what you mean. Yes.
Okay.
Okay, I'm with you, man.
I can see you keep on creating multiple documents, and we can just add the pages, ma'am, on the word, and control enter. It will add another page.
Oh yes, thank you very much. That's what I wanted. So I say control enter.
Yeah, control enter. If you are using a laptop keyboard.
Oh yeah.
Engineers.
Sanko.
No,
I've been doing this for years.
ITs.
Where were you?
Now
Where were you all this time?
Fix my printer.
Okay, let's go down here. Yeah. Minus 3x x plus x squared minus 1 to the power of half to the power of 3 over x squared minus 1 to the power of half. Do we agree on that one? Over,
okay.
X squared minus 1. Yeah.
Oh, now you removed the... Okay. crisscross.
So we can remove this one by this one, ne? But you notice that this one is the same as this one.
Yes, ma'am.
So meaning that this will be 9x plus x squared minus 1 to the power of half to the power of 3.
3.
Yeah.
Minus 3x x plus x squared minus 1 to the power of 1 over 2. Is it to the power of 3 as well?
Yeah.
Over x squared minus 1 to the power of half. Yeah, this.
And the quotient rule.
Okay. Are we happy up to that point? Because if we made a mistake somewhere, we are in trouble.
Hey.
I see the light.
I see darkness. Maybe I'm almost there to see the light.
Okay.
Yeah, no. It's to rewatch the video and see, man.
I hope we didn't make any mistakes.
We have this type of questions in exam. It's very long.
You might have it in the assignment.
Yo, imagine doing this in the exam is time consuming.
I'll make it 10 marks.
Yo.
Yeah, ma'am, it's not about the mark allocation. It's about the steps.
Okay.
Yeah, you can easily make a mistake here.
So do we have to?
I know, I understand. Don't worry, you won't get such a question.
Yeah.
Do we simplify it further, or do we continue the move on to the third derivative?
We still have to prove.
We still have to prove. Remember, we are proving.
Oh yeah, yo.
We're trying to. We found this. We want this.
We even lost the reason why we.
I even forgot. God, you were supposed to prove.
This question is tiresome.
Okay. You
Let's
should
go
do
on,
it
man.
because it might be there in the assignment. So what do you think we can do here, guys?
I'm gonna find the common denominator on the denominator, on the numerator. Sorry, ma'am.
So what is the common denominator in this case?
It's x squared minus 1 to the power of 1 over 2.
But why don't we say 3? Then we have 3. Then we have plus x. Oh, sorry, I forgot something. 3x plus x squared minus 1 to the power of half to the power of 3. Then 3 minus x over x squared minus 1 to the power of squared. Do you see that?
Yes, ma'am.
What's that?
Wait, what am I looking at?
I'm just saying yes, ma'am.
So I'm saying
Oh,
yes.
yeah, I do agree.
Wait, hold on. What am I looking at? Wait, let me look properly.
Yeah,
I see it. Yeah, I see it now. I needed to put on my glass, but I see it.
Okay.
Ma'am, what
And
did
then
you do?
let's simplify this. Because I think if we
I'm
simplify this, let's try to simplify this.
Hello, ma'am. I'm shaky on what you did there. Or what did you do?
I remove the common factor. I removed 3x here. I remain with 3 because if I say 3 times 9, I go back to this one. And I remove 3 and this one. I'm remaining with x there. 713.
Yeah, it makes sense.
713. Are we okay, guys?
Yeah,
Oh,
man,
you are tired like me now.
I just needed to put on my spectacles, but yeah, I'm okay.
We are following through.
And the person who said we should do number 4 is quiet. Oh,
No, I'm the one who said that was
quiet
me.
or left.
That was me.
Okay, I hope we haven't done a mistake up to this point. What else can we do here? Let's simplify this. Let's see.
Sorry, ma'am, the last step, what happened to the 9 there? What did you do? I didn't see
3
exactly
times
what
3
you
is
did.
9.
Factored it out.
Oh, okay.
I factored it out. Yeah, you guys are making me do something very long here.
You must make this 15 marks, man. 10 marks is too short.
This
I
one
won't take it.
Ma'am,
I
this
promise I
question
won't take it out in the exam.
is the type of question I will skip.
She will. She definitely will take this out in the exam. Believe
I
me.
won't, because it's taking time and you might make errors. Let's look at this, guys.
Okay.
Yeah, I feel like we might have made a mistake somewhere, but right, it's fine.
Let's keep going, man. Let's see the explosion. You know, we're already halfway.
Yeah, true. So we agree that this becomes, yeah, there's an explosion here. I don't know what's the explosion, but hey, yeah.
Everything that have to deal with proving is troublesome.
It is. Because one mistake, then you're in trouble.
10 marks gone, one mistake.
But we are still cooking.
We have to. So this is times 1 over x squared minus 1. Are we in trouble here?
Yeah, we're cooking it.
At this point, ma'am, I'm playing and I'm just following through.
Let's keep going. Let's keep going.
What happened to the denominator for the second time? The x squared minus 1 over half. What happened
took
to
it
it?
out
You
as
took
a
it
separate fraction.
Yeah.
as a separate fraction.
I know 1 over x squared minus 1 is the same as it being as your denominator.
But I thought that will change the sign somewhere. Won't it be negative? You just take it. Okay, 3 into x squared plus 1 over 3 times 3 x. I don't know.
Hey, we're almost there, comrades. We're almost there.
Ma'am, don't get lost on your calculations. I can see.
No, I feel like I'm lost, but let me see. 1 minus x squared. I feel like I've made an error somewhere.
Yeah, because everything we've done now is mathematically
No,
correct.
no.
Okay.
Okay, guys, can you see something here? I don't think this was necessary. You know why I'm saying that?
Why?
Which one? Why?
I feel like the steps here was not necessary. I'm seeing that now. Let me cut this part.
Yeah, remember when I was trying to do it on the side to find the common denominator of the numerator there. So the reason why I've been quiet, I've been trying to write it on my side. So I think I'm seeing flames.
You see this step, guys? Let's end here. You know why?
Okay.
Why?
Okay, let's end here. I'll tell you why.
Just common number.
Because if we look at our problem has x squared minus 1 here. Do you see that?
Yes.
Yeah.
Oh, yeah.
So I don't think it was necessary for us to go there. Let's end at this step. You see? So meaning the derivative dy, the second derivative is this one. Do you see that?
Yes, ma'am.
No,
if we leave
I don't see it.
If we leave it here instead of simplifying, so this whole simplification is just complicating everything here. If we leave this and we only end at this step over here, what happened is this x squared, let's write it here, x squared minus 1 times the second derivative, which is this one. So it's 9x plus x squared minus 1 to the power of 1 over that to the power of 3, right? Are we together there? Yeah. Minus 3x x plus x squared minus 1 to the power of half to the power of 3 over x squared minus 1 to the power of half. Right? The whole thing divided by what? X squared minus
X squared
1.
minus 1.
Do you see that this x squared cancels that x squared?
Okay.
Do you see that, guys?
Yeah, you see, we were supposed to multiply the x squared with the answer.
Yeah.
Okay.
Okay, are you looking to have the same type of term?
Oh, this x squared minus 1 is the one on the equation.
Yes, the one on the equation, it cancels the one on the denominator. That's why I'm saying these steps we're not supposed to simplify here.
Okay.
Does it make sense?
Okay. Yes.
So then,
so you see
it
plus,
means that plus x, what is our dy over dx if we remember it properly?
No, you don't remember.
It's this one here.
Okay.
Okay. I don't know why it's not pasting. So it's what? 3x plus x squared minus 1 to the power of half, 3 over x squared minus 1 to the power of half.
Plus
minus 9. What was our y? Yes, it's minus 9. How many seats? Do you remember why? It's. Can you please read this? X plus. How many seats? Can you please mute? Okay, plus 9 x squared square root. Okay, so plus 9 x plus, guys, I'm tired. X squared. This is x plus square root of x squared. Thank you.
X squared minus 1 all to the power of 3. Yeah.
Do you see that? Ne? Oh, we are proving that it's equals to 0.
Yeah.
I almost said equals to 0. Okay. So now let's look at this. We agree that this cancels this, ne? This cancels that, right? That's the first part. So then this is equals to, we're left with 9 x plus square root of x squared minus 1 to the power of 3. Right? We're left with that, isn't it? And then we are also left with this, which is minus 3x open bracket x squared plus x plus x squared minus 1 to the power of 1 over 2 to the power of 3 over x squared minus 1 over 3. I mean, x squared minus 1 to the power of 1 over 2. And then plus this one over here, which is 3x x plus x squared minus 1 over 2 to the power of 3 over x squared minus 1 to the power of 3. Minus this one, minus 9x plus square root of x squared minus 1 to the power of 3. Do you agree that this is equals to 0, guys? Sorry, this is to the power of 1 over 2. Look at this. Do you see there's a 9 here? There's a negative 9 here. There's a negative 9 open bracket x plus x squared square root of x squared minus 1 to the power of 3, which is the same as minus open bracket x plus square root of x squared minus 1 to the power of root 3. So meaning this one minus this one. Am I right? Look at this one is a minus here and there's a plus here.
And the other one
This
is the
whole
same.
thing
Yeah, okay, 0.
minus
Yeah,
is this
okay.
whole thing.
0.
Oh,
So
yeah.
0.
Yeah, it's equal to 0.
Yeah.
So what do we learn from here? There's
Question
something we
rule
learned.
is,
We learned that
no.
not always you have to do what?
Simplify.
Thank you.
Okay, I'm curious, man. Say we substituted that final simplified answer for the second derivative into the equation. Would it still give us the same result of it equaling 0?
It will, but what I've noticed was that when I got here, I had to multiply inside and then it was forming something very long, right? Then you go back to your question and say, okay, fine. If I don't simplify it, because that's where I started simplifying. If I don't simplify it, what will happen? That's where I went back to the derivative and started looking and I'm like, oh, there's an x squared minus 1. Meaning this, I don't have to simplify further. Therefore, my x squared minus 1 will cancel this one. And then I only have the top part. Yes. So not always you have to simplify.
Okay.
Yeah. So that's why I'm saying the more you practice the question, the more you see the tricks of saying, oh, okay, fine. At this point, I have to stop. At this point, I won't stop and whatsoever. Because when I got here, I'm like, but then I have to multiply inside and whatsoever. Let's go back to the original question and see. Then I notice, oh, that cancels the denominator. So it means I will only deal with the top part. So once I cancel the denominator, it means it will be easier for me to simplify. Luckily, once I canceled the denominator, I noticed that these terms are the same. This one is the same as this one. This one is the same as this one. So they cancel each other and give us a 0.
Okay. It makes sense, man.
Okay. So can we leave now?
One more question. I'm joking.
No.
I'm joking.
No, you were sleeping.
We're hungry now.
I am hungry.
3 hours.
Okay, is the question related to the work? Let's start there.
Oh yeah, I thought I said one more as a joke for example number 3.
No.
Oh, no, come
It's your homework. Bring it next Tuesday. It's your homework. Do it.
It's just a joke, guys. Just a joke.
Yo, my head is hot.
Mine is hot